Alright, so we have to restart this video because there was a lot of electrical noise in my audio. So restarting from this point, that lightning can burn a tree as it contains tremendous amounts of electrical energy. जो हमारे मेजर इलेक्ट्रिक इक्विपमेंट्स में वायरिंग होती है उसमें 3 कलर के तार होते हैं या वैसे भी आम तौर पे. तो लाइव वायर इज़ रेड इन कलर whereas न्यूट्रल वायर इज़ ब्लैक इन कलर and the earth wire is green in color. Also sockets की बात करें तो the earth pin is the longest among the three compared to neutral as well as earth wire, live wire. तो live pin, earth pin and neutral pin. live pin, neutral pin and earth pin, इन तीनों में से सबसे लंबा होता है earth pin. It is longest of the three so as to ensure that it is the first to connect the circuit when we push it in the socket, and it is the last to get disconnected from the circuit, and this is ensured for the safety of the electrical equipment. Then talking about electrical fuse, so it is a safety device which is used to prevent damage to the electrical circuit when excess current flows through it. The fuse works on the principle of heating effect of electrical current. It consists of a wire with low melting point and high resistance. It is connected in series. As the current increases beyond a limit, fuse melts and breaks off the circuit. The filament of halogen bulb is made of tungsten and sodium. When sodium burns, it turns into vapor and gives off a yellow color. So sodium vapor burns with yellow color, and sodium is there along with tungsten in the halogen bulbs. Then domestic electrical wiring is done in parallel in homes, where each section receives the equal amount of current. Each branch receives the equal amount of current when it is done in parallel. If one branch is broken in complete circuit, the other branches work in fine. That is the sole reason why we do the electrical wiring in homes in parallel. Now dry human body offers more resistance, that is 10 to the power 6 ohm, while the wet body offers lesser resistance. That's why a wet body drenched in rainwater will pass more amounts of current and suffer more, whereas dry human body offers more resistance. Alright, so कोई ये नहीं पूछेगा कितने ओम का रेसिस्टेंस ऑफर करता है, बस इतना भी अगर पता हो कि ड्राई ह्यूमन बॉडी ऑफर्स more resistance compared to the wet human body, तो भी काम चलेगा. Then tube lights are usually filled with mercury vapor and argon, whereas halogen lamps are filled with sodium vapor and tungsten, whereas tube lights are filled with mercury vapor as well as argon. When electrical energy is converted into motion, there is no heat loss, and this is probably the only sole principle because of which electricity works so efficiently. When electrical energy is converted into motion, there is no heat loss. That is why the flow of electrons doesn't cause heating effect. Now electrical motor is the device that converts electrical energy into mechanical energy, and 1000 watt hour. So 1000 watt hour is equal to 1 kilowatt hour, and that is equal to 1 unit. Okay, so you need to run an appliance of 1000 watt power consumption for 1 hour. तो आपका 1 kilowatt hour basically total power consumed हो जाएगा, or we can say in terms of meter units, that is 1 unit, 1 kilowatt hour or 1000 watt hour. Now sound travels slower but farther in colder air compared to warm air. Now I have already told you that sound travels faster in the denser mediums, and cold air is always dense compared to warm air. So sound travels, oh I'm sorry, ये गड़बड़ है, तो इसको ज़रा कंफर्म कर लेते हैं एक बार. अभी फ़िलहाल के लिए ये रट लो कि साउंड ट्रैवल्स स्लोअर बट फार्दर इन द कोल्डर एयर, ओके, कंपेयर टू वार्म एयर. सो यस, ज़्यादा हीटेड एयर होगी तो एयर मॉलिक्यूल will have greater energy and it will be easier for the sound to propagate. Sound is a longitudinal wave, and but even the humid air में sound of speed actually increases. But if it is cold, dry air, then the speed of the sound, I think, gets reduced, but the extent to which it is heard increases, right? So sound travels slower but farther in cold air. Sound travels slower but compared to warm air. So sound travels slower in cold air than in warm air, but it can travel farther in cold temperatures. Sound travels faster in warm air because air molecules move faster at higher temperatures, carrying sound waves more quickly. For example, 15 degrees Celsius, sound travels at 1.2 kilometers per hour. No, 1220 kilometers per hour. But at minus 56 degrees Celsius, it travels at 1056 kilometers per hour. So there's a difference of 100 miles per hour if you sort of change the temperature by approximately 70 degrees Celsius, right? So the speed gets reduced, but the distance gets increased. Sound travels farther in colder temperatures because sound waves bend away from the warm air and back towards the ground. Now that's the core reason. Sound travels farther in the colder temperatures because sound waves bend away from the warm air and back towards the ground, and then again gets reflected back. So sound travels farther because in colder temperatures because it bends away from the warmer air and hits the ground again, and this way it can propagate to farther distances in the colder regions. That is what is written here, that however the speed of sound gets reduced in colder temperatures compared to warm, but it travels for a farther distance. Now speed of sound amongst these three metals. So speed of sound will be greatest in iron because it is the most dense compared to aluminum and then copper. Let's check the relative densities of aluminum and copper. Which is more dense? Copper. So copper is denser than aluminum. Copper has a density of 8.96 grams per cubic centimeter. Aluminum is quite less dense, drastically less dense. So yes, so that means aluminum में सबसे slow जाएगी. Speed of sound in copper, aluminum and ये कैसे हो गया? Speed of sound copper बीच में होना चाहिए था ना? Arrange speed of sound in copper. So why can't the AI do? So you see that 5,100 meters per second is the speed of sound in aluminum, which is quite slow compared to 37,500 meters per second in copper. So which of the following is the speed of sound in copper and which in aluminum? And speed of sound in iron is definitely going to be even more, right? So speed of sound in iron. So that is 5120 meters per second, aluminum and copper. Speed of sound in iron, aluminum and copper. So you can see here that iron is the greatest and then comes aluminum in between. Why? The speed of sound varies depending on the medium it travels through. Sound travels fastest in solids, slower in liquids and slowest in gases. This is because the particles in solids are closer together than in liquids. But if we look at this chart, copper's density is 8.9 and the speed is quite high here, that is 6420. Speed of sound in different mediums, okay, 6420 meters per second copper mein hai. What about iron? So it is given here 5120 meters per second. I don't understand, this question lacks clear information. So the speed, look at this, so it is 343 meters per second in normal air. Now it is 5640 meters in glass and 5940 in steel. So sound travels faster in which, iron or aluminum? Sound travels faster in aluminum than iron. Sound travels fastest in aluminum because it is a solid, and sound travels fastest in solids. So at 25 degrees Celsius, the speed of sound in aluminum is around 6420 meters per second. Sound travels faster in iron than in air because iron is a solid and solids are packed together more tightly. Let's ask ChatGPT now. There's a lot of confusion regarding this. So arrange in increasing order. Let's see what the speed of sound in materials generally depends on the density and elasticity of the material. So it has given copper 3570 meters per second, iron 5130, okay, which is and aluminum is the fastest. Thus the increasing order with speed of sound is greatest in aluminum, iron comes in the middle and copper is the slowest. यहाँ क्या लिखा है? आयरन में ज़्यादा कर दिया है जबकि एल्यूमिनियम में फास्टेस्ट है. How is that possible? The speed of sound, let's copy and paste that first of all. Okay, I will do more research on this. Meanwhile, I'm moving on to the next topic, that is the function of choke is to provide high voltage enough for ionization to take place in the tube light, and after establishment and of ionization, limit the voltage across the tube. At the time of starting a tube light, the tube choke gives rise to high voltage by di by dt nearly 1000 volts by starter. On-off function, rate of change of voltage becomes high due to inductance of the choke. This high voltage starts ionization of the gases in the tube, that is mercury and argon. Once gas gets ionized and starts conducting, then the starter gets out of the circuit and the circuit is completed. Choke now reduces the voltage only to maintain the current, right? So that's how it works. Remember that just मोटा मोटा रटने के लिए कि जो चोक का इस्तेमाल करते हैं ट्यूबलाइट में, फर्स्ट ऑफ ऑल इट एक्ट्स एज एन इंडक्टर. सो चोक इन ट्यूबलाइट एक्ट्स एज एन इंडक्टर. Choke in the tube light acts as an inductor. Yes, in tube lights a choke also, which is also called as a ballast, acts as an inductor. Its primary function is to limit the amount of current flowing through the tube light, especially when it is first switched on. So everything happens so quickly. When we start the light, in older fluorescent tube lights, when the switch is turned on, the choke generates very high voltage through the starter to ionize the gas inside the tube. This high voltage helps in initiating the discharge, causing the tube to light up. Now, once the light is on, the choke then regulates and maintains the current, ensuring it stays within a safe limit, allowing the light to continue operating without flickering. Thus, the choke works as an inductor to both start the light and regulate the current during operation. तो ये पुराने ज़माने में होता था. It is also called as a ballast. So, choke में एक हिस्सा होता है that's called as a starter. What it does, ये एक्सट्रीमली हाई वोल्टेज पहले जनरेट करता है और इतना पोटेंशियल डिफरेंस इतना ज़्यादा कर देता है कि बहुत हाई अमाउंट ऑफ करंट पास होता है और उसकी वजह से जो अंदर गैस होती है वो आयनाइज हो जाती है. एक बार आयनाइजेशन कंप्लीट हो जाता है तो फिर ये पोटेंशियल डिफरेंस कम कर देता है, वोल्टेज कम कर देता है और फिर एक सीमित करंट फ्लो होता है जस्ट टू मेंटेन द करंट फ्लो. एंड एज लॉन्ग एज द करंट्स फ्लोइंग, the gases emit light and we are able to see. So that is the function of choke. I'll read that once again. The function of choke is to provide high voltage enough for ionization to take place in the tube light, and after the establishment of current and of ionization of the gases within, limit the voltage across the tube. At the time of starting a tube, choke gives rise to a high voltage, nearly 1000 volts by starter on-off function. Rate of change of voltage becomes high due to inductance of choke. This high voltage starts ionization of the gases in the tube. Once gas gets ionized and starts conducting, then the starter gets out of the circuit and the circuit is completed. Choke now reduces the voltage only to maintain the current. Alright. Now transformers can only work with alternating current, so that is also important. A mobile phone charger is a step down transformer. It does two things. It first lowers the voltage 220 volt to 9 volts and then converts AC to DC. So दो काम करता है. एक तो स्टेप डाउन ट्रांसफार्मर होता है मोबाइल चार्जर में, तो 220 वोल्ट से 9 वोल्ट कर देता है एंड देन कन्वर्ट्स द AC टू DC बिकॉज द बैटरी रिचार्ज रिक्वायर्स डायरेक्ट करंट एंड नॉट अल्टरनेटिंग करंट. ऑलराइट, सो ट्रांसफार्मर्स हाउएवर वर्क विद अल्टरनेटिंग करंट. अ मोबाइल चार्जर वर्क्स विद डायरेक्ट करंट. ठीक है. नाउ इलेक्ट्रिकल जनरेटर कन्वर्ट्स मैकेनिकल एनर्जी इनटू इलेक्ट्रिकल एनर्जी, व्हाइल इलेक्ट्रिक पंप कन्वर्ट्स इलेक्ट्रिक एनर्जी इनटू मैकेनिकल एनर्जी. ठीक है. तो जनरेटर जो है जो बिजली प्रदान करेगा और मैकेनिकल एनर्जी से, ठीक है, जबकि इलेक्ट्रिकल पंप जो है, पंप क्या है, वो इलेक्ट्रिक एनर्जी से मैकेनिकल एनर्जी करेगा टुल्लू वगैरह पानी चढ़ाने के लिए. नाउ AC जनरेटर, इसमें स्लिप रिंग्स का इस्तेमाल किया जाता है, जबकि DC जनरेटर में कम्यूटेटर. अब DC जनरेटर में हम एक जगह डायनामो में पढ़ चुके हैं, दैट वर्क्स ऑन द बेसिस ऑफ अ कम्यूटेटर. तो what is the corresponding device used in the AC devices? That is slip rings. So AC generator works on the principle of slip rings, whereas DC generator works on commutator. Then batteries can be charged only with DC. ये तो हम देख चुके हैं. This is done through rectifiers which convert AC to DC as opposed to inverters. तो अब यहाँ मोबाइल फ़ोन बैटरी चार्जर में इन्वर्टर तो लगाओगे नहीं इतना बड़ा, तो रेक्टिफायर का इस्तेमाल करते हैं, which also converts AC to DC. In India, distribution companies calculate consumption in kilowatt hours. In India, power is distributed at a frequency of 50 Hz. Now, अब ये तो आसान सा है, फ़ैन सबसे कम लेगा, उसके बाद टीवी, फिर इलेक्ट्रिक प्रेस, और सबसे अधिक लेगा पावर कंजम्पशन इलेक्ट्रिकल केटल. नाउ अर्थ हैज़ अ मैग्नेटिक फील्ड ड्यू टू कन्वेक्शन करंट्स विद इन. देन आर्टिफिशियल सैटेलाइट्स गेट पावर फ्रॉम द सोलार सेल्स, जो ऊपर चल रही हैं वो सोलार एनर्जी पे काम करती हैं. एसपी क्या होता है? स्पेस बेस्ड सोलार पावर बोलते हैं. स्पेस बेस्ड सोलार पावर इज़ अ सिस्टम फॉर द कलेक्शन ऑफ सोलार पावर इन स्पेस फॉर यूज़ ऑफ अर्थ. SB would differ from current solar collection methods in such a way that the means to collect energy would reside on an orbiting satellite instead of Earth's surface. The power is then transmitted via electromagnetic waves at 2.45 gigahertz to dedicated receiver stations at Earth. Rectana, which would convert energy back to electricity. This would ensure 99% uninterrupted throughout the year. Besides the enormity, APJ Abdul Kalam stated SBSP should be made a national goal. That is space-based solar power. That is space-based solar power. मेरे ख्याल से वही करते हैं जो आजकल बहुत वायरल हो रहा है कि ऊपर स्पेस में हम लोग ऑर्बिटिंग मिरर्स लगा देंगे. सो द पावर एक बार फिर से देख लेते हैं, या यहाँ पे एक बार देख लेते हैं इन सिंपल टर्म्स. एक्सप्लेन पावर refers to the concept of collecting solar energy in outer space and transmitting it to Earth. The idea is to place large solar power satellites in space where sunlight is abundant and uninterrupted, and then send that energy back to Earth in the form of microwaves or laser beams. So here's a breakdown. Large solar panels would be deployed in geostationary orbits where they can constantly collect sunlight. Space offers several advantages, including no atmospheric interferences, no day-night cycles, and no weather-related disruptions. Then the collected solar energy would be converted into electrical energy and transmitted wirelessly to Earth. The collected solar energy would be converted into electrical energy and transmitted wirelessly to Earth, typically using microwaves or less lasers. तो ये बहुत इंपॉर्टेंट है. माइक्रोवेव्स या लेज़र्स के फॉर्म में हम उसको धरती पे भेजते हैं, और ग्राउंड बेस्ड रिसीवर्स ऑफन लार्ज एंटीना एरेज नोन एज रेक्टेनास would capture this energy and convert it back into electricity for use, right? So electricity energy or electrical energy is transmitted in the form of wirelessly in the form of microwaves or lasers, which are then received by the rectinas and again converted back to electricity. Now receivers on Earth, these ground-based rectinas would be spread over large areas designed to capture and safely convert the beamed energy into usable electricity. These receivers would typically be located in remote areas. Right, so this is the entire explanation, and let's copy that and we will paste it here. It is not quite visible, so yes, I can move it down. We can. All right, now moving on. So we have covered solar based space based solar power. Now the power is then transmitted, okay, that we have covered. 2.45 gigahertz basically ये कहना चाह रहे हैं in the form of laser beams or microwaves. Now solar thermal technology converts solar energy into heat energy, which is then used to make electricity. ठीक है, so solar energy to heat energy and then heat energy to electrical energy. That is that. Silicon and thin film technology. So silicon and thin film technology, these are the two methods of photovoltaics. Silicon and thin film technology are the two methods of photovoltaics. Solar cells have semiconducting properties in which their electrons become excited and turned into electric current when struck by sunlight. So again, like I said, that semiconductor requires, as the temperature increases, their electrical conductivity increases, and on that basis the solar panels actually work. So solar cells or solar panels have semiconducting properties. And silicon and thin film technology, these are the two methods used in the photovoltaics. Thin film technology and silicon film technology. Silicon film and thin film technology are related to photovoltaics. Now solar cells have semiconducting properties in which their electrons become excited and turn into electric current when struck by sunlight. Now CFL is compact fluorescent lab. They offer longer service and more efficient. They are more efficient than traditional bulbs, which convert only 5 to 10% of electric energy. So okay, they are able to do 22% conversion, whereas this traditional bulbs only convert 5 to 10% of electrical energy to light. Now CFL uses mercury vapor with inert gases like neon, argon, xenon, krypton, एंड फॉस्फोर कोटिंग। तो 3 चीज़ होती है CFL में, मर्क्यूरी वेपर होता है, फिर एक इनर्ट गैस होती है और फॉस्फोर कोटिंग होती है। ये 3 चीज़ होती है CFL में। While CFLs have life cycle of 6,000 to 10,000 hours, LED can run for 50,000 hours and are based on semiconducting materials. So just like photovoltaics are based on semiconducting materials, even the LEDs have semiconducting materials. The gas inside the electric bulb are generally nitrogen, argon, to prevent the coil of tungsten from oxidation. ठीक है, तो अंदर नाइट्रोजन और आर्गन क्यों डाली जाती है? हम CFL की बात नहीं कर रहे हैं, हम इलेक्ट्रिक बल्ब की बात कर रहे हैं, ट्रेडिशनल इलेक्ट्रिक बल्ब। उसके अंदर नाइट्रोजन एज वेल एज आर्गन डाली जाती है टू प्रिवेंट द टंगस्टन फ्रॉम ऑक्सीडेशन। इफ पोटेंशियल डिफरेंस एंड करंट इज मेड ट्वाइस, पावर बिकम्स 4 टाइम्स। बिकॉज ये फॉर्मूला याद है, तो हाँ, तो पावर बिकम्स 4 टाइम्स। ठीक है, नाउ द हीट रिक्वायर्ड टू कन्वर्ट 1 ग्राम ऑफ आइस इनटू स्टीम इज एट 100 डिग्री सेल्सियस। द हीट required to convert 1 gram of ice into steam at 100 degrees Celsius is equal to the latent heat of melting, that is equal to the latent heat of melting plus boiling to make water at 0 degree to 100 degrees Celsius, boiling to make water at 0 to 100 degrees Celsius plus latent heat of vaporization। ये कैसे लिखा है समझ नहीं आ रहा है। The heat required to convert 1 gram of ice into steam at 100 degrees Celsius, so that is called as latent heat of melting. Okay, boiling to make water at 0 to 100 degrees Celsius, latent heat of vaporization. So I think यहाँ मैंने ये बताने की कोशिश की है what's the difference between latent heat, so what's the difference between latent heat of melting and latent heat of vaporization. The latent heat of melting and latent heat of vaporization are both forms of latent heat, which refers to the energy required to change the phase of a substance without changing its temperature. अच्छा, however they apply different to phase changes and involve different amounts of energies. अब अगर हम latent heat of melting जिसको हम fusion कहते हैं, latent heat of melting जिसको हम fusion बोल रहे हैं, so the latent heat of melting is the amount of energy required to change a substance from solid to a liquid at its melting point without changing its temperature. तो solid से liquid हो जाना without changing its liquid, तो that is latent heat of melting. Example for water, the latent heat of fusion is the energy needed to melt ice into liquid water at 0 degree Celsius. It is about 334 kilojoules per kg for water. ठीक है, तो ये एक पॉइंट याद कर लो, ये यहाँ लिखना ज़रूरी है। ठीक है, 334 kilojoules per kg of water, so that is the latent heat of melting for ice. Okay, then for water basically, then typically the latent heat of melting is lower than the latent heat of vaporization, because the energy required to overcome the forces holding the particle in a solid state is less than the required to overcome the forces in a liquid state. Again, self-explanatory, quite intuitive. So latent heat of melting will be lesser than the latent heat of vaporization. Now the latent heat of vaporization is the amount of energy required to change a substance from a liquid to gas at its boiling point without changing its temperature. For example, अब ये देख लो कितना ज़्यादा होता है। The latent heat of vaporization is the energy required to convert liquid water into steam at 100 degrees Celsius. It is around 2260 kilojoules per kg for water. तो ये तो ज़्यादा है, तो यही हम बताने की कोशिश कर रहे थे। ठीक है, तो अब ये क्लियर हो गया ना। अच्छा, तो इसीलिए ज़्यादा होती है बिकॉज एक्चुअली latent heat of vaporization में you actually add up the latent heat of melting plus the energy required to boil water or take temperature of water from 0 to 100 degrees Celsius and then plus the latent heat of vaporization. So that अब इन सबको जोड़ के काफ़ी ज़्यादा हो जाता है। तो putting the constant values 720 joules आ रहा है ये। So steam burns are worse than water because steam at 100 degrees Celsius has extra 540 joules of latent heat. तो अगर हम सिर्फ latent heat की बात करें तो यहाँ पे ये कह रहे हो कि 80 जूल तुम्हें चाहिए latent heat of melting के लिए, इसको 100 मान लो, तो इसको चाहिए 540। ठीक है, 80 जूल चाहिए मेल्टिंग के लिए, तो 540 जूल्स चाहिए latent heat of vaporization के लिए। Steam burns are worse because steam at 100 degree has extra 540 joules of latent heat। 720 जूल्स आ रहा है सब जोड़ जाड़ के। अब उसमें से तुम यह घटा दो 100 डिग्री ये वाला बॉइलिंग वाला और 80 latent heat of melting वाला, तो उतनी एक्स्ट्रा हीट एनर्जी होती है स्टीम में, इसीलिए स्टीम बर्न्स आर वर्स्ट। तो ये कंप्लीट हो गया मेरा। तो अब अगले वीडियो में ना हम पेज नंबर 9 से करना है मुझे, नहीं 10 से करना है। ओके, यहाँ से करना है उल्टा।